dear student, good morning to all. Welcome to the video lecture series on Digital System Laboratory. Our laboratory code is 18 SCS 307. Under this laboratory, already we are discussing 4 experiments. So in this session, let's we go to discuss 5th and 6th experiment. In this experiment, main aim to design and implement multiplexer and demultiplexer using both logic gates and some application ICs. So already you know how we go to develop the multiplexer and demultiplexer circuit using logic gates. Here we do that all the concept also, and also here we are using some application IC, how we go to implement the multiplexer and demultiplexer circuit using some application ICs. Like example, IC 74150. They have many number of applications ICs available to do the multiplexer and demultiplexer operation, but here we are using IC 74150. This IC 74150 that's used to do that multiplexer operation. In this IC have 16 input pin and 1 output pin. If we want to control that 16 input, from that 16 input we get it only 1 output. How we go to select the 1 output from that 16 input? You should record some selection lines. So selection line based we go to get any one output from that all the input. So we give the 16 pin input. So we need from that 16 pin you select any one output. You should record the 4 selection lines. In case we give the 8 input, for that time we want to from that 8 line we select any one output. We should record the 3 selection lines. Okay, so here IC 74150, there's an application IC already prefabricated inside the IC, the circuit. That IC have 16 input pin and 1 output pin. If you want to control, if you want to select from that 16 input, you get only 1 output. They have also have 4 selection lines also. So once I repeat that, this 74150, this is also one of the digital IC because of IC number start with 74. Any type of IC number start with 74, you automatically you understand that type of IC is called the digital IC. So from this IC number you should understand. So here also we are applying the operating power supply voltage. It's 5 voltage is enough to do that entire circuit. Okay, so here 74150 is a digital multiplexer IC. That is a 16:1 multiplexer that's used to perform that IC. And then IC 74154, this is a demultiplexer IC. This is also digital demultiplexer IC. Here we are using, here this is used to 1:16. Okay, 1:16, 1 input line, and from that 1 input we get the 16 output lines. Okay, so here also we are using 4 selection line that's used to do that operation. Okay, so let's we go to move on. We want to do this experiment. What are the apparatus required is required to do this laboratory? First we should need one digital IC trainer kit. Okay, one number, and then you need 3 input NAND gate. How we go to find that 3 input AND gate? 3 input AND gate. When we develop the encoder or decoder, for that time you should record the 3 input NAND gate. But now we are develop the multiplexer and demultiplexer. Here we are using 3 input AND gate. 3 input AND gate. How we go to find the 3 input AND gate? With the help of IC number. IC 7411, that's indicate the 3 input AND gate. So you record 2 number of IC 7411 3 input AND gate, and then IC 7432 OR gate you record 1, and then IC 7404 1 number NOT gate also needed. Okay, let's we go to move on. How we go to implement or design the multiplexer circuit using logic gates. Before we go to implement the multiplexer using logic gate, you should know some basic introduction about multiplexer. Okay, so multiplexer, it's mean transmitting a large number of information unit over a small number of channels or lines. Okay, that is nothing but from that many line you go to select only one line. That is called the multiplexer operation. A multiplexer is a digital multiplexer. A digital multiplexer is a combination circuit that selects binary information from one of many input lines and directs to a single output line. This is the operation of digital multiplexer. Is a combination circuit that selects binary information from one of many input lines and directs to a single output line. The selections of a particular input line is controlled by set of selection lines. So this selection lines always depends upon our how many number of inputs available or how many we want to control how many number of input we want to control. Based on that you go to set the selection line. Already I told for you selection lines always depends upon our input. For that example we give the 8 input. From that 8 input we want to direct any one output. For that time you should try out the 3 selection lines. Similar to same concept we give the 16 input. From that 16 input we want direct any one output. For that time we should try out the 4 selection lines. Okay, so normally there are 2 power n input lines and n selection lines whose bits combination determine which input is selected. Okay, this is a basic introduction about multiplexer. And then demultiplexer. The function of demultiplexer is in contrast to multiplexer function. It is opposite to multiplexer function. It takes information from one line and distribute it to a given number of output lines. For this reason, the demultiplexer is also known as a data distributor. Okay, so this multiplexer operation is nothing but it opposite to the multiplexer function. It takes information from one input line and distribute it to a given number of output line. Okay, so for that reason the demultiplexer is also known as a data distributor. So decoder can also be used as demultiplexer. In the 1:4 demultiplexer circuit, the data input lines goes to all of the AND gates. The data select lines enabled only one gate at a time, and the data on the data input line will pass through the selected gate to the associated data output line. So let's we go to see on black diagram for 4:1 multiplexer. So 4:1 multiplexer have 4 input, that's D0, D1, D2, D3. These all are the data input, 4 data input. So we want to get the data output from these 4 input. So we want to direct any one input to the output. So here 4 input available. So you should record the 2 data selection lines. So from that data selection lines, which one we want to connect, which one we want to direct with output port mainly depends upon our S0 and S1. Let's we go to see on functional diagram. So let's we go how we go to get the output. Like example, we give the 4 input. From the 4 input we get only one output. Okay, from that input we want to control that input lines with the help of selection lines. So that selection line S0 and S1 both are as a 0. For that time we get it output D0. Okay, output D0. And then S0 is 1 and S1 is a 0. For that time we get it output D1 data. And then S0 is 0 and S1 is 1. For that time we direct to the D2 output into the D2 input in our output. And then both are as 1. For that time you get the D3 input line direct to the output line. So this is a simple functional diagram in our 4:1 max. So let's we go to see on. So based on how you go to achieve this functional table with the help of this circuit diagram. There S1 is available, S0 is available. Both two are the selection line that is used to select which one is input direct to the output. Then that S0, S1 and both are as a 0. For that time we connect to both are as a 0. For that time you connect the D0 with the AND gate. For that okay, and then both S0 and S1, S0 0 and S1 is 1. For that time you connect that connect to the D2, and then S0 is 1, S0 is 0 and S1 is 1. For that time you connect with D2 with an AND gate, and then both are as 1. For that time you connect D3 with the AND gate. Finally you add that all the operation, finally you got it Y0. So now we get it truth table. After you verify the circuit diagram available here. Based on the circuit diagram, we go to establish the circuit and then verify its truth table. Both are as 0. For that time you got it output D. Output is D0. So D0, that is the input line. There we give the data 0. For that time output also 0. And there we give the 1 value. For that time output also 1. So output Y always depends upon our D0 input. So that is the first combination of input. Selection line both are as 0. And then output get the D1 for S0 is S1 is 0 and S0 is 1. For that time you got it output D1. So the output depends on only for the D1 input. And then D2 output depends on only for when we apply the S1 equal to 1 and S0 equal to 0. For the time output depends on D2 input. And then S1 and S0 both selection lines are 0. For that time we got it output D3. Output depends on D3. We set the 0. For that time output 0. And then we set the D3 input is 1. For that time output is 1. When we apply the both selection lines are 1. This is our multiplexer circuit. So based on that multiplexer circuit, you go to implement that we go to implement this circuit after you verify this truth table. Okay, then next we go to discuss about block diagram for 1:4 multiplexer. Here we apply only one single input line data, and from that single input line we get it four output line. Okay, so we want to need the 8 output line. For that time you set the 3 selection line. We want to need the 16 output line. For that time you set the 4 selection line. So always output line, how many number of output you needed, how many number of output needed, that all are the output line mainly depends upon our selection lines. Okay, here we are designed the 1:4 marks. We need the we give the 1 input. From that 1 input we want to direct the 4 channel of output. So we need the 4 channel of output. You write out only two selection line, it's enough to achieve this operation. So now here also same concept. S0 and S1 both are as a selection line, both are as a 0. For that time what we will give X is a input. Okay, what we will give the input for that input get from that 0. Okay, D0, and then 0 1. For that time get the output from the D1, and then when we apply the S1 equal to 1 and S0 equal to 0, for that time you get the output from the D2, and then when we apply both input are 1, for that time you get the output from the D3. Okay, so this is our circuit diagram. Based on this circuit diagram, you go to implement the demultiplexer. Okay, so now we are discuss only for how we go to design and implement the multiplexer and demultiplexer using logic gates. Let's we go to move on how we go to implement the multiplexer circuit using 74150 IC. Actually this 74150 IC is a digital IC. This is one of the application oriented IC. This is used to do only for this specific operation, because of this IC, inside this IC already prefabricated some circuits. Okay, that IC perform only for that response. Okay, that IC respond only for the particular operations. Okay, so this IC 74150 is a 16x1 multiplexer IC. 16x1 it's mean for 16 input line. From that 16 input we get it only one output. So from that 16 input we want to direct only one output. So already you know basic concept about the multiplexer concept. We give the 16 input line. From that 16 input line we get only for the single output. How we go to get only single output from that 16 input? How many number of selection lines used to do that operation? So 16 input available. From that 16 input we direct only one output. You should require the 4 selection line. In case we design the 8:1 max, for that time 8 input available. From that 8 we want to direct only one output. For that time you should require the 3 selection line. But here 74150 is fabricated IC. Here already IC fabricated with 16 input to 1 output. So 16 input to 1 output, there should have 4 selection lines. So here totally this 74150 IC have 24 pin. That 24 pin, okay, 1 to 8 and 23 to 16. Totally 16 pin that's used to provide the input pin, and then ground and VCC. 12th pin is ground pin and 24th pin is VCC. Actually lot of pins available there, so if you want to apply the higher voltage, that's not required. Okay, this is also 7/4 series. Okay, this IC start with also 7/4 series. This is also one of the digital IC. So here also we are operating voltage, here also we apply plus 5 voltage, it's enough to operate this circuit. Okay, so totally 24 pin available. There 16 pin is used to provide the input, and 4 pin that's used to select the selection lines, and 1 pin that's our output, and 2 pin that's used to provide the power supply. So pin 1 to 8 input and 24 to 16 input, and then pin 11, 13, 14, 15 that's used to provide the selection line, and pin 12 that's used to connect to the ground potential, and then pin 24 that's used to connect the plus 5 voltage VCC. So okay, so this IC 74150 that's used to do that 16x1 multiplexer. Okay, so based on that pin diagram, you go to implement the connection. So based on that connection, you go to verify the 16x1 multiplexers, and then pin diagram for IC 74154. This is also one of the digital demultiplexer IC. This IC is used to do that 1:16 demultiplexer. Okay, that means from that one input we get it more than 16 output channel. So from that one we get it 16 output. How many number of selection lines is needed? Here also we should need 4 selection lines. So this IC also have the 24 pin. There 16 pin that's used to get the output, and 1 pin that's used to provide the input, and 4 pin that's used to control the that 4 pin that's used to do that selection control line, and 2 pin that's used to provide the power supply. There 1 to 11 and 14, 15, 16, 17, these all are used to apply the input, these all are used to get the output from that IC, and then pin 19 or 18 that's used to get the output, and pin 23 to 20 that is used to do that selection line or control line, and pin 12 that's used to connect to the terminal, and pin 24 that is used to provide the plus 5 voltage VCC. So this is our IC 7415 pin diagram. From that pin diagram you go to establish or we go to implement the connection after you verify the 1:16 demultiplexer circuit. So from this experiment we know how we go to implement the multiplexer and demultiplexer circuit using logic gates and some application ICs. So here we are using only for the 4:1 or 1:4 multiplexer and demultiplexer design using logic gates. If you want to need the 8:1 multiplexer, automatically you go to improve the selection line. From that selection line you go to improve the input, and from that selection line you go to improve the output line in our demultiplexer. So okay, are you clear? Okay, next laboratory we are discussing how we go to design the 4-bit adder. Okay, next class we are discuss this concept. Okay, thank you, bye.